All right, so now that we've got events, we're going to start expanding by bringing events together, creating new events, and create a whole library and a whole language with events. So the first thing we're going to talk about is the intersect. So if you give me two events, say A and event B, I'm going to talk about this new event, which is that both A and B consist of this new event. So, for example, there is the notation we use. We use A, upside down cup, B. This is the event that we have both A and B. So, for example, if the event A is that a 65-year-old woman is alive at 70, and the event B is that a 65-year-old man is dead at 70, if they married, then the event A and B is that she will be a widow at age 70. Okay, so we want both, that she is alive at 70 and that he is dead at 70. Right? So that's A and B. To help us in thinking about events and putting events together and probability of events, John Venn, a philosopher, came up with this idea of a Venn diagram. And a Venn diagram is as follows. You start off with the whole space S. So this is everything. Everything is represented by this space S. So a particular event might be a dot on this, okay? And then we got the event A. So there's the event A. So if anything occurs like inside A, then we say the event A has happened. So that would be the event A has happened. Something out here means the event A has not happened. Okay, so that's the event A. Then we also had the event B. So these are the sets of points that give us the event B. So now we've got 4 areas. We've got points out here, and points out there is neither A nor B. Then we've got points here. Now think of the points of A, where we can break them up into 2 groups. Those here, those are A but not B. And then here, those points are both A and B. And then the points on B here are B but not A. So we just defined A and B. So A and B is this area here where we have both A and B. So all the points in here give you both A and B. The other operation we need is union. So union is a union B. There is the notation for A union B. Says either A or B or both. So it's not the exclusionary or. It's either A or B or both. So when we do, for example, when we roll a 6-sided die, we either get a 1 or a 2 or a 3 or a 4 or a 5 or a 6. If we roll it twice, then the event A might be that we roll a 7, and the event B might be that we roll an 11. And so a union B might be roll a 7 or an 11 when we roll this die twice. So that's union. So now we've got intersection that says both have to happen at the same time, and union that says either or, either one or the other, or both happen at the same time. So going back to our Venn diagram, here's A, here's B, and now there's A union B. So A union B is all 3 of those little areas. So remember we said here we only have A, but that's okay, because that means A happened, B didn't happen. Here B happened, but A didn't happen. That's okay. That's good for A union B. And then here we both happened, and that's okay. That's good for A union B also. So there's A union B. Lastly, we come up with the idea of a complement. And this is complement with an E, not with an I. So it's not, you look great today. That's a complement with an I. This is a complement with an E. It's denoted by A complement, A super C. and that's the event not A. Okay? So if the event A is I live to be 25, and the event A complement is I do not live to be 25, so dead by 25. Now, with the Venn diagram, if that's the event A, this is the event A complement. So everything out here is A complement. And obviously then the complement of the complement is just A. It's amazing how much we can do just with those three operations. For example, we can define the null event, usually denoted by a 0 with a line through it. It's the event that cannot happen. It's a contradiction. So for example, can A happen at the same time as not A happening? And the answer is no. Those can't happen together. So A intersect A complement is the null event. It just cannot happen. You can't have it both ways. This leads us to a very important set of events. And those are mutually exclusive events. The definition of a pair of mutually exclusive events is that they cannot happen together. So either one happens or the other, but you can't have both of them happening together. So A, here's an example, A, live to be 25, B, die before your 10th birthday, then you can't have both. All right? And with the Venn diagram, it means this, that they separate. This is extremely useful for attacking problems which are very complex and they're very involved, and we have a huge amount of information. Then what we can do is break it up into little modules and know that only one of these can happen at a time, and then go in there and solve this one, and then go back and then solve this one, and so on, and then put them all together. That's the whole idea of modularity, and it's very important for computer programming, etc. All right, so here we call it mutually exclusive events.